Was it an earthquake? No, that's just the awesomeness of this video. It cannot contain the epicness of molecular geometry that we're about to learn. This is Mr. Pone, and we're going to talk about Vesper theory, valence shell, electron pair repulsion. And the idea for Vesper theory is that electron pairs are going to want to be as far apart as possible. If you had two electrons near one another, they're going to repulse. Positives, two like charges will repel. Two protons near each other will repel. A negative and a positive will come together. So we're going to look at that principle in terms of determining the shapes of molecules, and we're going to see a very easy method of doing so. So let's look at a few examples here, and let's say we have beryllium chloride. This has a linear shape. Why? Because we have a central atom surrounded by two things, and the idea is these electron pairs on the outside of it, they want to be as far apart from one another as possible, and a 180-degree angle does that. If you had three electron pairs, they're going to get a triangular shape. It's actually called trigonoplanar. We'll talk about that. But the idea is that these things are going to want to be as far apart as possible because the electrons want to be as spread out as possible. They're all pushing on each other. If we had four things around a central atom, you're going to get this sort of, we're going to see tetrahedral shape. And that's because the electron pairs want to be as far apart as possible. They don't want to be near one another. They're spreading out. So there's going to be a very distinct and strict pattern to the geometry of simple molecules that we are going to look at. And we're going to look at a whole host of shapes. Carbon dioxide is linear. That means 180 degrees. Why? Because a full circle is 360. Bent, we'll talk about bent in a little while. And trigonal pyramidal as well is a little more complicated. Trigonal planar, if you had one atom surrounded by three in the same plane, these would obviously be 120 degrees each because a circle has 360 degrees. And there's T-shaped and other things going on, but we'll talk about them. So we have some basic shapes we're going to use. Linear. This is two atoms connected together. This is one central atom. The red is a central atom surrounded by two other ones. Again, a central atom surrounded by three. It's going to be trigonal planar, 120-degree angles. Bent or angular, and we're going to talk about the case of water. These little green things are lone electron pairs. Tetrahedral, trigonal pyramidal, trigonal bipyramidal, octahedral. And I like how Tyler DeWitt teaches this in his video, so I kind of adopted the same question set. It makes, I think, this process very easily. So what we're going to do is we're going to take molecules like this, and what you're going to have to do is I'm going to give you a molecule, and I'm going to ask you, well, what's the shape of it? Tell me the final molecular geometry of it. And you're going to use these four questions. This is our guide to do it. So we have CO2. And the first thing you need to be able to do is draw the Lewis structure. If you can't draw Lewis structures for these, you cannot determine their geometry. And for time considerations, this is what the structure would look like for carbon dioxide. And so we're just going to use the final Lewis structure, the preferred Lewis structure, to determine the geometry of carbon dioxide. And this one's going to be easy because it is a central atom surrounded by two things. So maybe you're thinking it's linear, but that could be different depending on the Lewis structure. In this case, it's going to be true. But what we ask ourselves is how many things are there around the central atom? So this is the central atom. How many things are around it? And what we see is we have, well, what we're asking is in terms of bonds and lone electron pairs. And a double bond counts as one. So there's one double bond around it and another one. There's two things around the central atom. So what structure is this based on? Which picture has two things around a central atom? Well, this is the only one with two things around a central atom, so it's based on a linear structure. Are there any atoms replaced by lone electron pairs? No, not in this one. We don't have any lone electron pairs here. So the final structure is linear, and the bond angles are 180 degrees. So that's straightforward in the case of carbon dioxide. Alright, so now we have boron trichloride that we're moving to. And first thing we got to do is draw the Lewis structure. And once we do that, we have boron trichloride. Remember, boron can violate the octet rule. How many things are there around a central atom? A double bond is one. And an electron pair is also one. But we have a central atom. How many things are on it? One bond, two bonds, three bonds. So there's three things around a central atom. What structure is it based on? Which picture has a central atom with three things around it? Well, there's actually one here. And there is another one, but this has something else. It has three atoms around it and a lone electron pair, which is what those green things are. So we're going to stick with the trigonal planar. Which atoms are replaced by lone electron pairs? We don't have any lone electron pairs around boron. So the final molecular geometry is trigonal planar. And the bond angles are 120 degrees. Next one, we're going to draw water, and we're going to see why water is bent. So the Lewis structure for water looks something like this. And the question is, what is our central atom? Our central atom is oxygen. And how many things are around that central atom? How many things are there around a central atom? Well, there's a bond. There's another bond. There's one pair of electrons. And there's another pair of electrons. So oxygen is essentially surrounded by 4 things. So in which case do we have an atom surrounded by 4 things? Well, we'd have to actually go down here. Tetrahedral. So water is based on a tetrahedral structure. But now, which atoms are replaced by lone electron pairs? Well, 2 of these aren't actually atoms in water. 2 of these things are lone electron pairs, so we cross them off. And we end up with just a little bent structure, which is what water is, or we end up with something like this. Bent or angular. You have 2 things around a central atom, 2 atoms around a central atom, and 2 electron pairs. And these electron pairs actually bend water molecules a little bit more, so we end up with a 104.5 degree angle instead of the 109.5. So again, for water, there's 4 things around the central atom, but 2 of them are lone electron pairs. So you could just say there's 2 things by the atom and 2 electron pairs, or it's based on a tetrahedral shape, 4 things around a central atom, but we get rid of 2 of the atoms because they're just electron pairs. But these electron pairs actually bend the water molecule a little bit more, so instead of this being 109.5 degrees, it's going to be 104.5 because there's a little extra repulsion when we have electron pairs. And this is not drawn to scale. So this is called bent or angular. And let's look at ammonia versus nitrate. I think I usually give you a test question of some form on this. Ammonia is NH3. This is how we draw the Lewis structure for ammonia. So how many things are there around the central atom? We have 1, 2, 3, 4 things around the central atom. That lone electron pair counts as 1. So nitrogen is surrounded by 4 things. What structure is it based on? It's based on tetrahedral. Which atoms are replaced by lone electron pairs? Recall that one of these atoms is not an atom. It's a lone electron pair. So we cross it off, pick one of them, and you end up with a structure like this, or exactly this right here. The final structure is going to be trigonal pyramidal, because you have 3 things around a central atom with 1 lone electron pair. So that's going to be what ammonia will look like in 3D. So this is trigonal pyramidal, and now we're going to do the same thing for the nitrate ion. And the first thing we got to ask is, how many things are there around a central atom? Well, we have a bond, and remember, a double bond counts as 1. So we have 3 things around the central atom. So nitrate is an atom with 3 things around it, and that's going to be trigonal planar. An atom with 3 things around it will be trigonal planar. So NH3 and NO3 are different. Why? They have a different molecular geometry because of this lone electron pair. So these 4 questions will help you. Just kind of ask how many things are on a central atom. And to me, I asked what structure is it based on. If there's 4 things around it, even if some are lone electron pairs, use the tetrahedral, then just get rid of anything that are lone electron pairs and you go back to one of these shapes. So you could have trigonal, bipyramidal, octahedral, and so on. So, Mr. Sapone, hopefully that helps you with molecular geometry.